Morning, everyone. We are so happy to be here at Google I/O with y'all today. I'm Khanh. I'm a developer relations engineer on the Dart and Flutter team at Google. Thank you. So there's a saying that a picture is worth 1,000 words. As an amateur photographer myself, I tend to agree with this statement. Whenever I travel somewhere new, I love to take photos to capture the moment and remember that place. Sort of like a souvenir. In fact, I took all the photos that you see on screen right now. So over the years, I found myself in this habit of taking these photos, coming home, going through them one by one, editing them, and then somehow I end up in this Wikipedia rabbit hole, reading page after page, learning about the location that I just captured on my camera. Quite a bit more than 1,000 words, I'd say. As Kaz and I were talking about this project, we wondered, what if we had an app for this? An app that lets you dive deeper and understand more about the photos that you've just taken. So in this talk, we're going to walk you through our journey building a GenAI-powered Flutter app that lets users dive deeper and learn more about their photographs. Let's take a look. So you can select a photo. Here, I'll pick a photo that I took in Monterey, California. Give it a moment, and it will identify the subject, in this case, the lone cypress tree, and gets a description of that subject as well. You want to learn more? Tap Tell Me More. And here you can chat with Khanh, your AI agent, and ask her questions about the subject of that photo. And if you happen to be wandering around Mountain View and come across some cool Google merch, like our favorite Chrome Dino pin, you can take a photo with the app, and it'll identify the product, whether it's official Google merch, and how much it costs. And if you're an impulse shopper like me, it'll even give you a direct link to purchase the product as well. Now that you've seen the app, we'll show you how it was built. This talk is broken down into 4 parts. First, we'll walk you through the journey building a prompt for the Gemini API. Then we'll show you how we built a Flutter app that sends a prompt along with the user-selected photo to the Gemini API using the Vertex AI for Firebase Dart SDK. After that, we'll tell you why you should be using AI agents and show you how you can build one with Vertex AI Agent Builder. And finally, we'll show you how we added the chat UI to our app that lets users chat with the agent and how we can make the app adaptive across all 6 of Flutter's target platforms. As you can see, we cover a little bit of everything in this talk. If you're interested in learning about Gen AI, we've got you covered. If you're a cloud engineer, you'll get to see some of the cool new tooling that we have at Google Cloud. And if you're an app developer, we've got some Flutter code for you as well. Ultimately, we're bringing all of these skill sets together to build something awesome. Whether you're interested in Flutter, cloud, app development, or generative AI, by the end of this talk, you're going to have a good idea of what the process looks like for building a generative AI agent-powered app with Vertex AI Agent Builder and Flutter from beginning to end. Kaz, would you like to kick us off?
Thank you, Khanh. Hi, I'm Kaz. I'm developer advocate for the Cloud AI team. And I'd like to introduce first introduce the Gemini models. The Gemini family of the models. The Gemini family of models is the most capable and the models we have ever built, and that is a result of the large-scale collaboration across Google, including Google DeepMind and Google Research Team. The latest version, the Gemini 1.5 Pro, has 3 major features. The first one is the mixture of expert, or MOE architecture. That means we are not using the entire large language model for every request or prediction. Rather than that, for each specific tasks, we use the only part of the models, the so-called expert networks, so that you can get a much higher efficiency and much shorter latency. Especially you can experience on that with the latest model, Gemini 1.5 Flash. And the second, it supports a very large context window. Yesterday, we announced that this model supports now up to 2 million tokens. How long is that? How large is that? You can just upload twice the document that has twice the size of the entire Lord of the Rings series as a single prompt. And you can ask anything, any events or any people, anything about the story. And also, you can upload the documents, multiple videos, or many tens or hundreds of the images in a single prompt and ask anything about them. The third, multimodal understanding reasoning. As I mentioned, it doesn't support only text. It supports also the videos and the images and audios as well. So for example, you can let the Gemini taking all the tens of minutes of the video and summarize what happened inside the video. Or you can ask the Gemini to take the very long, complex, intricate programming code and make any suggestions on the improvements on the code. In this example you are seeing at the right, we have uploaded 44 minutes of the video, Buster Keaton movie, and with an illustration of the water tower and a person underneath, and asked what happens when it happens. Then the Gemini replies that this happens at 15 minutes, 32 seconds. And you can get started with the Gemini model by using the Google Cloud Vertex AI Studio. It's so easy, as you can seeing on the video right now. You can just open the console, this of the studio, and choose the model. You can choose Gemini 1.5 Pro, or maybe you can try out 1.5 Flash that is announced yesterday, and build a prompt. You can write the text prompt, and also you can upload the image, like an image of the Chrome Dynapin, and press submit, and you'll be seeing the result within seconds. That's so easy. So we have tried the uploading the photos took like this one. This is a very beautiful photo taken by Khanh of the falling water. So you can upload this image to the console and ask, what is this? Then you get a response like this. This is a falling water, a house designed by Frank Lloyd Wright, the famous architect in 1935, and blah, blah, blah. And the response already looks so great. The model understands deeply about the house. But as we are building the GenAI app, you have to ask some other things to the Gemini. Especially, you want to read the response in a machine-readable format. So we need to tweak this prompt a bit. Here we have added 4 requests in the prompt. First, name of the object. The second, description. The third, suggested questions for the object, so the user can explore more about the object. And also, as a final request, we asked the Gemini to output the response in JSON format. Then you will get a response like this. Now, Gemini 1.5 Pro model supports the JSON format output so that the Flutter app can easily proceed and extract any element from it. Now we have the prompt to get the information about the building or the object in the photo. I'd like to pass the stage back to Khanh so she can share how we can incorporate this prompt in her Flutter app.
Thank you, Kaz. Cool. Let's talk about building a Flutter app. Before we jump in, for the folks who aren't familiar, what is Flutter? Well, Flutter is an open source multi-platform app development framework. Lets you write one code base that runs on Android, iOS, web, macOS, Windows, and Linux. So once we had the structure of the data that was coming back from the Gemini API, we could jump into building the app. The first thing that we did was create a data model that maps to the JSON that we'd be getting back from the Gemini API. You can see the metadata object has an image, name, description, and a list of suggested questions. From there, we started building the Quick ID feature. So this feature presents the user with the option to take a photo or select an existing image, sends it along with a prompt to the Gemini API, and identifies the subject of that image. You'll see throughout this talk, we leaned heavily on pub.dev, Flutter and Dart's official package repository, to bring this app to life. To implement the camera and image selection, we used 3 packages: Permission Handler, Image Picker, and Image Gallery Saver. Permission Handler was used to request the necessary device permissions for accessing the camera and camera roll. Image Picker provided functionality for selecting the image from the camera roll. Now, there's an added perk here. If your users are on Android, it'll trigger the default Android photo picker, which has built-in Google Photos integration. So you can actually pick from photos that have been shared with you through Google Photos, but aren't necessarily directly on your camera roll. Image Picker also provides functionality to launch the camera and take a new photo as well. The only thing that changed in our code between picking a photo from the camera roll and taking a new photo was the Image Picker source parameter. Regardless of the source, Image Picker gives us the image file and we can decide what to do with it. If it's a new photo, we'll use Image Gallery Saver to save it to the camera roll and then call the send vertex message method. Speaking of, to call the Gemini API in order to identify the subject in the photo, we use the Firebase Vertex AI package, also known as the Vertex AI for Firebase Dart SDK, which is now officially in public preview. Calling the Vertex AI Gemini API is essentially making a REST call. However, trust me when I say that the SDK makes the process much easier since it handles most of the configuration and setup that you need to do. So to start, we initialize the model instance and specify the specific Gemini model that we want to use, Gemini 1.5 Pro. We also added configurations like setting the temperature to 0 so that we could minimize the randomness and get more consistent output from the Gemini API each time. And since we're using Gemini 1.5 Pro, we also get to set the response type to JSON, so no more checking for and removing those backticks in the response. Then we define the method to send the prompt to the API called sendVertexMessage. This message packages up the prompt that Kaz shared earlier, along with the user-selected image, and it sends it to the Gemini API. If you want to optimize for faster response times, you can resize the image to be smaller as well. When a response comes back, it gets decoded and stored as a metadata state object. And here's a pro tip. Since the Gemini API is returning the data in JSON format, we use Dart's pattern matching for a less verbose way of pulling out all the information that we needed. Here, it's taking the JSON map and grabbing the values for the keys name, description, suggested questions, and assigns it to local variables. As someone who came from a language without pattern matching, I love it. And by the way, we just introduced experimental support for macros in Dart, so I'm looking forward to a future where we don't even have to write these methods. Woo! Fantastic job by the Dart team, by the way. So once we have the metadata object representing the response, we pass it to our custom card widget to display it on the screen. You can see we also provided a loading state variable, which triggers that shimmer placeholder that you see there. And if you're familiar with the Google Generative AI package, you're probably thinking that this code looks really, really familiar. That's because Vertex AI for Firebase Dart SDK is built on top of the Google Generative AI package. Different endpoints, but similar structure. The best part is, if you're already familiar with the Google Generative AI package, you'll be right at home with Vertex AI for Firebase Dart SDK. And there you have it, a mobile app with a fully built Quick ID feature that identifies the subject of the photo. Now, Kaz, what are some of the considerations that we have to think about when we're building a generative AI app like this one?
Okay. So let's think about how you can improve this app. When you want to deploy this app to as a production app for the corporation and enterprises, or you want to use this app for any wide variety of the use cases. First, we have to realize that information any LLM generates could not be the latest information because LLM is trained with the data that can have with the data when they have trained the model. So it could not be the latest information you have right now. There could be the cases where the app shows some outdated information or so-called hallucination. So you could get the hallucinated answer that is not based on the facts. So you may want to connect the model to the external data source. If your users are expecting, for example, the enterprise data source that is proprietary to a specific company, then you need to have a way to connect the model to those data sources, or so-called grounding the models. But how would you do that? If you write a prompt, you want to write a prompt to extract what would be the most important keyword from the entire user request or prompt to build an SQL query or search query for the search engines or the vector database. And what if you have the multiple data sources, not only a single data source, but the multiple, like 5 servers, or the documents, or anything, or maybe the internet, the web pages? Then how you can choose the right data source for solving a problem requested by the specific user request? For example, in our app's use case, we have 2 different images. One is the falling water images that could be maybe found in the Wikipedia. The another one is the Chrome dinner pin. And Wikipedia doesn't have the information of how much does it cost. So how would you solve this problem? To solve these problems, we'd like to introduce the concept of the AI agents to our Flutter app. Why do we need AI agent? In the early days of the generative AI, many people have been using the LLM models alone without any external data store or anything. So they could be possibly get the outdated information, don't have any access to the proprietary data, or maybe you could be seeing any hallucinated answers. So that's the reason why we are starting to hear the new buzzword called RAG, or Retrieval Augmented Generation. That is all about connecting or grounding the LLM model with the external data set. With RAG, you can combine the LLM models with the backend retrieval system. This could be anything you have, like it could be a vector database. Somehow the vector database is the most popular choice right now, but you can even use the SQL database or usual search engine, like Elasticsearch, as the retrieval backend. So every user request, you can take some important query from that and make the query against those the search engines or databases to find the most relevant information and embed that documentation or information as a part of the prompt for the Gemini or LLM models, so that you can feed the latest information or company's proprietary information as a part of the prompt to reduce the risk of the hallucination and get the latest information as the response from the LLM. So that was RAG. And now we have AI agent. This is a natural evolution from RAG. In this architecture, you deploy an application called agent to the runtime environment. This agent has a capability of the reasoning and orchestration to the RAG system. Orchestration with agent works in 2 ways. First, it takes a user request and determines which external data source, or we call them as tools, could provide the best way to find relevant information. For example, if you get the query on the falling water, maybe the model thinks Wikipedia could be the right place to find it. Or user request can involve some actions rather than the query. For example, the users may want to reserve a ticket or make some purchase on the product or items. Then you can also access the other APIs to make those transactions if you want. That's the first one. The second aspect of the orchestration is that the agent determines how to convert the user request to the function call of the tool. With AI agent, you don't have to take care of any converting the user request, taking out any important keywords and put into the SQL or the vector database query. In later section, I will explain how these reasoning and orchestration work. So the AI agent works just like a human agent for the user, but it's running inside the runtime, and who knows what does the user request mean, and also that knows the best tool to answer your question. And it also knows how to map the user request to the function calls with those multiple tools. That is AI agent. So in short, the AI agent is an application that uses the power of the LLM for reasoning and orchestration with the external tools to achieve the goal. It inherits all the benefits of RAG, such as grounding with the external data source to get the latest information and lower the risk of the hallucination. Plus, it adds the flexibility like a human agent for choosing the right tool or trying the multiple tools to satisfy the request. AI agent is a new way of dynamically and semantically integrate a loosely coupled distributed system with the power of LLM. Last April, Google announced a new suite of products called Vertex AI Agent Builder, which is a suite contains multiple products and tools for building AI agent with the orchestration, tool, and grounding with search engines. With Vertex AI Agent Builder, there are different approaches and projects for building AI agents. In this session, we'd like to focus on Vertex AI reasoning engine that is also called as LangChain on Vertex. That is, as its name suggests, it's a product based on the most popular open source tool called LangChain that is used for the building chatbots and the RAG systems. With the flexibility and ecosystem of the LangChain, reasoning engine tightly integrates it with the Google Cloud services with a fully managed runtime for the AI agents. Reasoning engine lets developers transparently access the benefit of another service called function calling, which works like a magic wand to easily map the LLM output to your Python function. Also, we will use the Vertex AI search for retrieving the data from external data source. So let's see how to build AI agent with reasoning engine. First, you start defining your tool by writing a Python code like this. This function uses Wikipedia API to find a relevant Wikipedia page for a specified object and returns a full text of the page. This tool could be used to feed the facts and the latest information on any popular object on your photos. And now the most interesting part is here. You don't have to write any other metadata or based on the open API specification. No more writing the JSON metadata for the function. Instead, you can just write yet another usual Python function with the proper function signature and the comment. This is the most important part. So that the function calling can read those comments and the function signature and find out when this function should be used to answer to the user request and how to map the user request to the parameters of this function. In this example, the comment explains that this function will search for a Wikipedia page for a specified object. So if the agent receives an user request that is likely to be solved by Wikipedia pages, then the agent calls this function. Then what about the Google Shop items like a Chrome Dino pin you saw earlier? Wikipedia page cannot solve this problem. So we need another tool. To show the flexibility of AI agent, we have added another tool for searching with the Google Merchandise Shop dataset. This tool can feed the product name, description, pricing, and the page link on any Google Shop products. This function uses Vertex AI search endpoint that runs a query on the Google Shop dataset. Vertex AI search is a search engine that shares the cutting-edge search technology with Google Search, packaged as the out-of-the-box, fully managed service. If you have any enterprise data on BigQuery, Cloud Storage, CSV, or JSON file, or any other popular data sources data format, then you can easily import them into the Vertex AI search and build an index and run a query on them. In my case, when I was building this demo, it took only a couple of hours for importing the entire dataset from the Google Shop dataset to the Vertex AI search, building an index, and define this function as a tool for the reasoning engine. That was so quick. Now we have two tools, Wikipedia search tool and Google Shop search tool. So next thing we have to do is create an agent with the two tools. When this agent receives a user request, function calling checks what kind of functions are available with these tools, and then picks a tool that should provide the best way to satisfy the user request and forward the request to its function. This is how the reasoning and orchestration work inside the reasoning engine. Lastly, you can deploy the agent to the reasoning engine runtime. It creates a container image that encapsulates the agent and the tools. The runtime provides a scalable, fully managed platform for the agent without the effort of designing, building, and operating your own infrastructure for providing AI agents. And that's it. You can start using the agent with the Vertex AI SDK or REST API from your app by specifying which agent you want to use and passing the request. With the Flutter app we are building now, we used Cloud Run for a simple endpoint for receiving the requests from the app and pass them to the reasoning engine runtime. This agent running on the runtime does the reasoning and orchestration with the two tools. For example, if the request is related to any popular objects and landmarks, then the agent calls Wikipedia tool. That calls the Wikipedia API. Or if the user request is related to any Google Shop items like a Chrome dinner pin, the agent calls the Google Shop tool. That uses the Vertex AI search to looking for the Chrome dinner pin in the Google Shop dataset. So that's how the backend works. Now it's ready to integrate this agent with the Flutter app. Back to Khanh.
Thanks, Kaz. All right, let's talk about integrating the AI agent with Flutter. We'll integrate the AI agent into our app using a chat interface. This Tell Me More feature presents the user with a chat UI where they can ask their AI agent, Khanh, for more information about the subject in the photo. We'll surface Gemini's suggested questions here as well. To start off, we use the HTTP package to make our network calls. So we define the ask agent method to reach out and hit that Cloud Run endpoint that Kaz had put together. We construct a URI, including a query string, which includes the subject name, description, and the user's question. Depending on the tools available in the Vertex agent, you could specify a particular data source or tool, but the agent has been good at deciding the right tool for us, so we left that up to the agent to decide. Send the request to the endpoint, and finally decode the response and return it as a string. One of my first projects as a Flutter developer was building a chat UI. I was just learning, so I thought I had to build everything from scratch. I mean, Flutter is meant for putting pixels on the screen. It's been a few years now, and I know that there's many devs out there who've already built fantastic chat UIs and chat apps with Flutter. So instead of reinventing the wheel, I reached for the Flutter Chat UI package. Out of the box, the package gives you essentially everything that you need to create a chat. It handles most of the chat boilerplate, and you can configure it how you want it. You can see I constructed the chat object and then configured a theme, determined whether it should display avatars and names, specified the current user so that it knows which messages came from you, the current user on the device. Some more interesting configurations, the typing indicator. The last thing that you want is for the user to send a question and then wonder, is anything really happening on the back end right now? So the typing indicator shows the 3 bouncing dots indicating that the agent is currently typing based on loading state. The list bottom widget is a convenient place to surface Gemini's suggested questions so that when the chat is first shown, the user can pick from a list of suggested questions or just use it as inspiration. And last but not least, we also provided a list of messages and an onSend callback. The handle send pressed method constructs a new message, adds it to the messages list, and sends it off to the agent by calling, well, send message to agent. Send message to agent sets the state to loading, calls our ask agent method from earlier to hit the Cloud Run API, gets the result back and constructs a new message, adds that to the list of messages, and sets the loading state back to false to clear that agent is typing status. And there you have it. With the Tell Me More feature, users can now ask for more information about the subject in their photo. That's great. We've completed our app. Since we built with Flutter, we can just package it up and ship it to all the platforms. Right? Not yet. Sorry to burst your bubble there. So, because we know better than that, we know that different devices can provide very different user experiences. Using a mobile app on a desktop doesn't feel too great. So if you're a developer building multi-platform apps, you want to optimize your app so that users can benefit from the user experience for their particular device. A phone, a tablet, a laptop, and desktop, they all have very different configurations and user experiences. Touchscreen or keyboard? How big is the display? Is there a camera? So there's a lot to think about as a developer, especially when you start considering all the various capabilities for every single device. So I like to break down these user device considerations into two categories: responsive and adaptive. Responsive is a change in how your app looks based on screen or window size. And adaptive is based on your app's features based on the device configuration. Flutter has widgets and packages to help with optimizing for both. So let's look into a few of the modifications that we made to the mobile app so that it's responsive and adaptive for the best experience across different devices. Let's start by looking at how we made our app responsive. First, we adjusted the layout to be horizontal on wider displays. This lets users get full use out of their nice large monitors and minimizes the need to scroll. We didn't have to change anything about the card containing metadata. We only rearranged how the widgets were laid out. It's a column on mobile, but a row on wider screens. Plus, instead of pushing the new chat window as a new screen on larger displays, we can make it pop up as an overlay window in the main screen. Again, we use the same exact chat widget regardless of device. With Flutter, we can reuse a lot of the components like buttons, cards, and even in this case, the chat widget across devices, so that minimizes the amount of new code that we have to write as we expand on our target devices. While we're on the topic of reusing code, here's a little fun fact. Google's first-party Flutter apps have an average of 97% code share. As said by one of my favorite TV show hosts, you don't have to take my word for it. The classroom team, for example, saw a 3x increase in velocity from a mixture of only writing each feature once or at most 1.5 times in scenarios where there were heavy native components, among other benefits. Talk about efficiency. So then when we're moving from mobile to larger devices again, like tablet, desktop, or web, another change you'll often see is the navigation bar. Don't get me wrong, I love a navigation bar on mobile, but have you ever seen a navigation bar on a large screen like a tablet or a desktop? It looks like an XL version of the app that wasn't exactly designed with that particular device in mind. So while we have a navigation bar on mobile, we changed that to a navigation rail on large screens. For all of these responsive designs, we used an abstract measure and branch framework. The idea is that you first find shared data between the components, decide how you want to measure the available space, and then conditionally return UI components. It's a really quick and succinct way to summarize a process that, personally, I found could otherwise be very overwhelming. So my teammates Reed and Tyler actually came up with this concept, and I'm going to steal it from now on. Speaking of, if you're wondering, that's really vague, where is the code? Well, it's in Tyler and Reed's session, where they'll be going into far more detail on how to build adaptive UIs in Flutter. Definitely check it out, and they have some fantastic tips in their talk. So that was responsive. Now let's talk about adaptive, how we change the functionality of our app based on device configuration. A common way to determine what platform the app is running on is to use code that looks like this. The Dart platform class exposes constant values that tell you if the app is compiled for Android, iOS, Linux, Mac, or Windows. And the Flutter Foundation library's K is web constant will tell you if you're running on web. This is great for something like styling your app if you want to make sure everything fits in the native platform design system, but you don't want to assume things like input modality based on platform. Instead of checking the platform and assuming certain behaviors, we can define a capabilities class to determine whether a device has, well, certain capabilities. Here, we define methods to determine whether a device has a camera or a keyboard. Then you can write a plugin to check the native platform's APIs for the exact hardware that you need. Now, I know this piece is a little hand-wavy here. Please check out flutterdev/adaptive for more in-depth guidance on this piece. So from there, we can define a policy class to determine whether certain features are supported in our app based on the device's capabilities. So here we've written code that determines if taking a picture is supported, depending on whether the device has a camera. And as long as the device has a physical keyboard, the app supports keyboard shortcuts. Keep in mind, just because a device can do something doesn't mean that it should, especially if it's an anti-pattern for that particular platform. Something like pull to refresh doesn't really feel right on your web browser. So in that case, you can stack device capabilities for more complex configurations. So for example, support pull to refresh only if the device has a touchscreen, a small display, and is not web. Defining this kind of a device policy makes our UI code more readable and understandable, but it also makes developers' lives easier when it comes to mocking device configurations for testing as well. Plus, if device capabilities change in the future, or Flutter adds support for more platforms, you only have to update your code in one place, in the policy, instead of updating it in every single widget that uses keyboard shortcuts, for example. With that background squared away, the first adaptive change that we made was the showing a take a photo button. We should make sure to check the device policy before displaying the button, make sure that you can actually take a photo on that device. The other adaptive feature is for the folks using a physical keyboard. We introduced a keyboard shortcut Control-T to bring up the chat UI. We built a shortcut helper widget to wrap our UI. The widget is built using the callback shortcuts widget, which takes a map of key bindings to callbacks and a child widget. Flutter has a more powerful shortcuts, actions, and intense keyboard shortcut system, but for our simple use case, the callback shortcuts widget gets the job done. So here you can see we pass the map, the shortcut helper, a map of keyboard shortcut bindings and a child, our content, whatever's being displayed on the screen. And finally, for that last bit of polish, of course, we had to implement dark mode. Since we used materials color scheme from seed method to generate our color scheme, we passed the brightness state variable that was controlled by a switch on the settings page. And after all that work, we have an app that helps you dive deeper and learn more about your photographs, powered by Flutter and Vertex Agent. Accessible on every device, whether that be a regular old mobile phone, foldable device, tablet, and web or desktop. Woo! Phew, okay, that was a lot of information in 40 minutes. Let's recap everything we've talked about. Kaz, you want to start?
Sure. For Gemini, we have introduced the Gemini 1.5 Pro. The model provides the multimodal AI, so our Flutter app can easily pass the photo to the model and get information about the object. Also, with the large language context window, you could even pass tens or hundreds of the photos at once or long video as the single prompt to the model and have it explain about the content. Secondly, we have explained the concept of the AI agents and how to use the Vertex AI agent builder to design and deploy them easily. It provides scalable, fully managed runtime for the AI agents. The agent provides the reasoning and orchestration capabilities that dynamically integrates the Gemini app with a variety of the external tools and data sources. Not only the Wikipedia pages or the Google Shop dataset, you could also add your own external datasets and API as tools. What about the Flutter, Khanh?
Well, as you saw, a single Flutter app can be made available across multiple platforms for users on desktop, mobile, and web. You build for every screen while optimizing for the best experience on those devices. Reach more users on more platforms, the bonus of scalable, faster development cycles with one code base. Flutter is flexible, and the goal is to help you build and ship awesome apps. Now, Kaz, if anyone's watching our talk and wants to learn more about building with Gemini, how can they do that?
Sure. If you're interested in the Gemini models on the Vertex AI, please go to Google search and search with Vertex AI Gemini API and Vertex AI Agent Builder to find the documents and tutorials. What about the Flutter?
Well, if you're interested in building with Flutter, try it out. Head to flutter.dev/getstarted to experience what we mean when we talk about a great developer experience. And for those of you who are already a part of the Dart and Flutter community, and I know there's a lot of you here, check out the new Vertex AI for Firebase Dart SDK and let us know what you think. Ultimately, Google Cloud and Flutter are both great tools for developers to scale their productivity individually, but they're even better together. Together, they're a value multiplier that can help developers be more productive. As developers, we want to have the right tool for the right job, and ultimately, we believe Flutter and Google Cloud offers you the flexibility to build what you want and the option to scale and reach more users if and when you need it. Vertex AI Agent Builder makes building chat agents accessible to developers, and Flutter makes the agent accessible to your end users. For more on all things Flutter, please check out the What's New in Flutter talk. My teammates Kevin and John will be covering all the coolest new Flutter updates. It's been a privilege to be here with y'all today. Thank you so much for taking the time out of your day and giving us the opportunity to share our project with you. If you'd like to watch a replay of this talk, it'll be on YouTube. We hope that we've inspired you to think about all the cool projects that are possible with Flutter and Google Cloud. and we can't wait to see what you build. Happy Google I/O, and we'll see you around.
Thank you.